we can wait and start at 1.
All right.
Okay. What kind of phone are you taking these pictures with?
I'm using an iPhone.
iPhone, okay. Is that the same phone you used last year, or is this a new phone?
Oh, this is just my dad's phone. I don't use my cell phone.
Okay.
So,
There it is. I've had a number of new students using iPhones, and for some reason the picture they take isn't very clear, and I can only guess that there's a setting when you take your pictures of normal, fine, or super fine. At least I have that on my Samsung. I'm not real sure how an iPhone works, but this is fine here. The resolution on these are great. So hold on a moment. Let me open up my Windows Journal. And okay, so we're working with radicals. Let's start with the square root of 48. How can I simplify that?
what goes into 48 twice? It's the same number. What time?
48 is not a perfect square number, so there is no number that squares to 48. But it can be simplified. Simplification merely allows us to take one of the factors of 48 outside the radical. Okay? Now, a real basic principle with radicals is this. If I'm taking the square root of a times b, that's the same thing as the square root of a times the square root of b. Likewise, if I'm dividing a by the b, and taking the square root of that quotient, I can separate that into the square root of a divided by the square root of b. Okay? So these two rules are really critical here with handling all of these kind of problems. So what if I were to break up this 48 into the square root of 4 times the square root of 12? That's a true statement because 4 times 12 is 48. And now I can actually pull a 2 out. So that would be that. And it would be simplified, not all the way, because if I want to break up square root of 12, then I would say, well, that's square root of 4 times square root of 3. And then I could take another 2 out. So I'm going to have 2 times 2 root 3, and my final answer is 4 root 3. And that's fully simplified because I can't do anything left with the root 3. Okay? Now, I can do this problem quicker if I notice something from the very get-go. And that would be that not only is 48 4 times 12, but it's also 16 times 3. And that gets at the final answer 3 steps quicker. In other words, I don't have to do any of those steps there. I merely have to convert the square root of 16 to 4, and I have my final answer. So whenever you're simplifying these radical expressions, the idea is to find a factor of 48 that is the largest perfect square you can find. Now, when I say perfect square numbers, let's go through them. 1, 4, 9, 16, 25, 36, 49, 64, 81. These are perfect square numbers. That's 1 squared, 2 squared, 3 squared, and so forth. So when you're looking for your factors, these are the numbers you want to look for. In other words, if I was aware of my perfect square numbers, then I would recognize that, yeah, 16 is also a factor of 48. And I would go straight to that. What I was trying to point out by doing it the slow way the first time was the fact that even if you don't find the largest perfect square number that's a factor of 48, you'll eventually still get to the right answer. If all you do is keep pulling out 4s, because 4 is a perfect square number. Okay? So this list right here is a really good list of numbers to be familiar with. Those are your perfect square numbers. Okay, let me leave that up there. Let's look at B. Here we have the square root of 36 over 49. So what's the first thing I want to do to that?
You want to find the square root of 36?
Well, the first thing I want to do is say that that's the equivalent to this.
Okay.
Right? Based on those first rules that I was, in other words, the square root of A divided by B is the square root of A divided by the square root of B. Now, these happen to both be perfect square numbers. So what's the answer here?
So 6.
6 divided by...
Is it 7 or...
Yeah. In other words, there's 49 on that list. So 49 is 7 squared. So that's a pretty easy one once you do that first step. In other words, it's a lot harder to view this as taking the square root of 36 49ths. But it's really easy to view it as the square root of 36 divided by the square root of 49. Okay?
All right.
All right. Let me give you one. I'm going to make up another one. How would you handle that? And when they say no decimals in the instructions, they want all answers left in radical format. They don't want you making a decimal approximation of it. In other words, that last answer was 4 root 3. It was not 4 times 1.71. What would I do with the square root of 200?
Would you figure out what the biggest...
Give me factors of 200, one of which has to be a perfect square number. In other words, here's my perfect square numbers again. So the goal here is to go through these numbers and see if any of them divide evenly into 200. And let me put the last one down there, which I left off. That's 10 squared.
So that would be 100.
Yeah. So what's this? In other words, the square root of 200 is equal to what?
Would be 2 times the square root of 10?
Yeah.
Square root of 100.
The square root of, let's do this methodically here. In other words, let's always do this step. And now you can change the square root of 100 to 10. So there's your answer. Now, notice that I could have done this the slow way by just kept dividing by 4 or 25. This is also 25 times 8. Well, 25 is a perfect square number, so that would be 5 root 8. But root 8 is root 4 times root 2. So I can pull another 2 out. You understand what I'm saying when I say pull a 2 out?
Yeah.
Okay. So this would give me 10 root 2. You're always going to get to the same final answer. It's just how many steps it takes to get there. So if you want to get there in as few steps as possible, try to find the largest perfect square factor of that number. All right, let's go on. We don't want to spend our whole session on radicals. So solve this algebraically. No decimals, okay? What's one of the first, what's something I can do to simplify this thing and make it less numbers?
24.
Okay, that's a reasonable first step. Now what can I do?
You could divide.
Okay, so what's the next line?
Would be 4x squared divided by 4 equals 64 divided by 4.
Okay, so I don't need to write all of that. In other words, I can do this and now simplify. What does that equal?
X squared equals, crap.
That's 16. That's not necessarily something that I would say you need to have memorized. In other words, this is a big two-digit number divided by a small digit number. You need to be able to do that, but there's nothing wrong with using a calculator to do it. Now, what's the final step?
You divide once more.
No, how do I solve? I've got x squared equals 16. How do I solve for x? In other words, my final answer needs to be that on one side of the equation. How would I get x on one side of the equation? And I need nothing but numbers on the other side. I don't want x's on the other side of the equation. So what could I do? About take the square root of both sides. When I take the square root of both sides from that step right there, well, the square root of x squared is x. What's the square root of 16?
That's 4.
It's actually plus or minus 4. And I would say about 90% of my students almost always leave off the plus or minus, but you will lose points on these problems if you don't put it down there. There are two solutions. 4 is a solution. Notice why negative 4 is also a solution. Negative 4 times negative 4 equals 16, positive 16. So both of these work. Okay? Now, let's consider doing this one other way, which guarantees you'll never forget the plus minus. That way was actually the easiest way to do it, but it opens up the chance of always forgetting the plus minus. Well, typically when we see a quadratic, that's what this is, the correct way to solve it is to put 0 on one side and everything else on the other. So one other way to do this problem would be, and I almost like it better, subtract 40 from both sides. Now that's the typical way you solve a quadratic, and that's the only reason I like it better, is because you can solve all quadratics this method. Okay, what's the next step if I'm doing it this method? Can I simplify this?
Would you divide?
I could divide every term by 4. I can divide that by 4, I can divide that by 4, and I can divide that by 4. Which now gives me x squared minus 16 equals 0. And now if we solve this in the more traditional manner, factor x squared minus 16. What's that called? That has its own name. Difference of...
I'm not sure.
Difference of perfect squares. I don't know if we covered difference of perfect squares last semester towards the end. I thought we did. I'm not sure, but whenever you have the difference of perfect squares, such as a squared minus b squared, that's the difference of perfect squares, it always factors into a minus b times a plus b. Always. Well, this is the difference of perfect squares. So this is going to factor into x minus 4 times x plus 4. And notice now if I go to solve for x, well, x can be either equal to plus 4 or based on this one, x can be equal to minus 4. So we get the correct answer with no chance of mistake by doing it this way, by treating it as a typical quadratic. In other words, there's no correct or incorrect way to do it. I do like to show you both methods, though. All right, let's go to 3. I'm sure you've had difference of perfect squares merely because they're going to teach you difference of perfect squares before they give you a problem like this. This is a quadratic. We could try to factor it. Oh, it does factor. Factor this for me.
Wouldn't there be x times x, and would be plus 2 and plus 2?
Okay, the signs have to be what based on that?
Opposite. So it would be plus 2 and minus.
Well, it's plus and minus, first of all. Now, we need two numbers here that multiply to 21. Right?
Yep.
In other words, we can't have a 2 and a 2. That would give us a 4 there. The fact that we're looking at a 21 there means we've got to have either 21 and 1 or 7 and 3. And when you're factoring, we want the two factors to subtract, because of that negative sign, to the number 4, to the coefficient of the middle term. Well, 7 and 3 work perfect. Always put the larger of the two factors with the sign of the middle term. So the 7 goes there, the 3 goes there, and notice that that works. If I do my little double smiley test, this is plus multiplying the inside terms and the outside terms and adding it together. That's how you get the middle term. So it works. So the easiest way to solve this problem is by factoring it. Giving you two solutions. What are they?
X equals negative 3 and x equals 7?
Opposite signs. In other words, when I get to this point here, I'm able to say, because this theorem in algebra says that if you multiply two things together and you get 0, then set both of them equal to 0 and solve. So I'm going to set x plus 7 equal to 0, and I'm going to set x minus 3 equal to 0. Well, when I solve that, I end up with x equals minus 7 and x equal plus 3. So be careful of that mistake. It's always the opposite sign of what you see here in terms of the solution. Okay, you with me?
Yep.
Okay. So, unfortunately, this was the easiest way to solve the problem, but the question said solve it by completing the square. So, let's go back and solve it by completing the square and see if we get the same answer. Now, if you're completing the square to solve a quadratic, the best first step is to take it out of standard format and get it to that format, where you have the two terms that have x in it on the left and you have a number on the right. This is the step that most people want to make when they go to solve a quadratic, even though traditionally it's not the best step to take. But if you're completing the square, this is what you have to do. Okay? Now, do you remember the completing the square process?
No, I was sick for the week that we were.
Okay, well, it's pretty standard. Take half of the coefficient of the x term and square it and add it. So what would that give me?
Would it be plus 4?
Okay, I cannot arbitrarily just add 4 to the left side of the equation unless I add it to the right side of the equation also. So I can do that. Okay. Now, why did I do that? Why did I take half of that and square it? It's because it now allows me to write this as a binomial term squared. That now becomes x plus 2 quantity squared, like that. And that's the reason we do it, is because now we have a situation where I can solve this by taking the square root of both sides. What's the next line if I take the square root of both sides? When you take the square root of the left side, what do you get?
You get x plus 2.
When you take the square root of the right side, what do you get?
5.
No. What's missing? The thing I said 95% of my students forget.
Oh, plus and minus.
Okay, and you'll see why that's so important. Okay, now we still have to solve for x. So x becomes subtracting 2 from both sides. Notice what two answers this produces. Minus 2 plus 5 is equal to a plus 3. Minus 2 minus 5 is equal to a minus 7. So I get the same two answers I got doing it the easy way. But this does teach you how to complete the square. Let's do one more completing the square. Only because completing the square is a pretty big task. It's something you definitely have to know, and me just showing you how to do one isn't the way to learn it. The way to learn it is to have you do some. This time I'm going to make that, say, minus 22. In other words, the reason I changed it was because this cannot be factored very easily. I cannot find factors of 22 that subtract to the number 4. So I can't solve this by factoring. I could solve it by substituting it into the quadratic formula, which most people hate doing. Let's solve it by completing the square. What's the first step?
You put x squared plus 4x.
And leave room, because we know we're going to be completing the square, so I know I'm going to add something right there. First of all, I got to take my 22 to the other side. So far I have not changed anything. So now, how do I complete the square?
You take half of the 4x and then square that.
Actually, just half of the 4. It's not half of the 4x. It's only half of its coefficient. So I add 4 there. Have to add 4 to the other side. I still have the same thing I started with. I haven't changed anything. What does this become? Now I can write this as a binomial squared, which is my purpose. That's why I completed the square.
Becomes x squared plus 2 squared?
There's my binomial quantity squared. And that's key. Let me write that a little bit lower so it's not. That's the key part of the process. The reason is that once I get it to this, I can solve it by relatively simple means, by taking the square root of both sides. In other words, once I can get it to this step where I have a linear factor here, squared, quantity squared, and this, so what's the next line?
Be x plus 2
What's the first thing you want to write?
Plus and minus.
Square root of 26. Just like that.
All right.
So, my solution is what?
It would be x equals minus 2 plus or minus that square root of 26.
Yeah, and square root of 26 is simplified. That, you'll notice, is 13 times 2, but 13 times 2, neither of those numbers is a perfect square, so I cannot pull a whole number out of that. Square root of 26 is simplified. So, and of course what this means is I have two answers, minus 2 plus square root of 26, and minus 2 minus square root of 26. Notice also what that looks like. That looks like a solution if you to put it into the quadratic formula. That's what all the answers look like when you get it out, right? It's got that plus minus there.
I'm sorry, what was that?
This answer that we're looking at here, minus 2 plus or minus the square root of 26, looks just like an answer you would get had you plugged everything into the quadratic formula. Have you had to do that yet?
I'm not.
The quadratic formula? All right, well, let's wait until we get to a problem before I go into that. All right, number 4. These categories are jumping around pretty quickly, and I'm not sure how much time to spend on each one. We could spend a whole session on completing the square. We could spend a whole session on reducing radicals. So, a little reluctant to skip so quickly between each different discipline, merely because it doesn't give you a chance to practice it and learn it. In other words, just hearing it one time and doing one problem really isn't the way to go. But we'll keep chugging here. If this is the elementary or parent function, what's the difference between this over here? In other words, it says list the transformations.
It's been reflected.
Okay. Reflected about what axis?
Would be over the x.
Reflected over x. That's the first thing. There's two other things going on. You can list them in either order. You always want to list your reflections first at the top. Okay, what else is happening? What's the consequences of that 2 right there?
Doesn't that mean there's a vertical stretch?
Good. So it's a vertical stretch by a factor of 2. And finally, what's the consequences of that negative 1?
Is that a vertical shift of negative 1?
Vertical shift down by 1. Okay, good. I think you are in pretty good shape with that. Let's see, how about number 5? Same original elementary function. what's going on to it? Oh, there it is. In other words, what's happening? We got 1, 2, 3 things happening to this also. What's the consequences of that?
You know something, David? Your pen didn't show up on ours. Whatever you wrote down didn't show up.
I haven't written anything. I'm just looking at the original document. Can you read that?
Okay, that's fine.
In other words, we're looking at the y equals 1/2 times x minus 2 quantity squared plus 3. What are the 3 transformations that are taking place with that?
There's a vertical shift up by 3.
Okay. That's 1. Takes care of that. What's the consequences of this x minus 2?
Is that a horizontal shift by -2 to the left?
Okay. It's a horizontal shift by 2, and it's to the right. Only because this is the standard format, x minus h, as it is with most everything you're going to be dealing with in algebra. It's always going to be x minus h, or y minus k. It's never plus. So if this is the general format, and I'm looking at x minus 2, then h has to be a positive 2. And positive means shift to the right. Okay?
All right.
So if I had x plus 2, that means h would have to be a negative 2, and I would have a shift of 2 units to the left.
All right.
So basically negative means go to the right, positive means go to the left. Okay? So I've got a horizontal shift, not a stretch, a shift. Neither this plus 3 changes the shape of the curve, nor this minus 2 changes the shape of the curve. Just moves everything 2 units to the right. The third and final thing, what's the consequences of that 1/2?
Is that a vertical stretch?
The last problem was a vertical stretch because it had a 2. This is 1/2. 1 is the dividing line. In other words, numbers greater than 1 are vertical stretches. Numbers between 0 and 1 are vertical squeezes or scrunches or whatever you want to call it. Instead of having your parabola look like this, it flattens it out like that. When you have numbers that are between 0 and 1 as your vertical multipliers. Okay?
Okay.
Okay, number 6, they want us to list the transformations and graph it. What are the transformations? Oops, hold on.
Yeah. It's reflected.
I'm sorry, what?
It's reflected.
Okay, so we got reflection over what? You have to say what, because it can be reflected over the y or the x-axis.
It's over the x.
Okay. What else?
There's a, let's see, horizontal shift of left 2.
Okay. Left 2. And finally, plus 4.
And then a vertical shift of up 4.
Okay, now let's graph it. And I'll start with the parent function. Okay? So, you do all reflections first. And it makes a difference. If you do your reflections after you do the other two, you're going to get the final graph wrong. So let me draw this in a different pen. So the first thing I would do is reflect it. That makes it look like that. Second thing I'm going to do is horizontally shift it left 2 units. Makes it look like that. And finally, I'm going to go up 4 units. Makes it look like that. And that's the graph of that function. Now, you might ask, what causes a reflection over the y-axis? It's when the negative sign is inside the parentheses. In other words, if I gave you this, that is different than this. This one, the negative sign is outside the parentheses. It's a reflection over x. This one, the negative sign is inside the parentheses. It's a reflection over y. Well, if you take your parabola, your standard parabola, and you reflect it over y, it's the same thing. And as it should be, because if I do this algebra, that's the same as x squared. It shouldn't look any different. Okay?
All right.
That is also in vertex mode. In other words, if I put my quadratic, that's a quadratic, it's got x squared. If I put it in standard mode, here's what it would look like. That is standard vertex mode, where h and k are the vertex. So what's the vertex of this parabola? Remember, I've got it minus times x plus 2 squared plus 4. So what's h? Remember, the vertex is h comma k. So from this, we need to figure out what h is and what k is.
So k would equal 4.
Okay, what's h?
Would that be 4 as well?
Match those two up. What's h?
It's 2.
Negative 2. In other words, the only way I can end up with x plus 2 is if I start x minus a minus 2. So h has to be minus 2 for me to end up with x plus 2. So h is minus 2. My vertex is minus 2 comma 4. The beauty of the vertex format is that you can read the vertex without doing any more work. You know, you don't have to do minus b over 2a. You don't have to solve for anything. If it's in vertex format, you can read the vertex directly off of it. Does this parabola open up or down?
Does it open down?
Yes. Negative signs open down, positive signs open up. In this case, a is negative 1. Okay?
Okay.
Vertex, maximum or minimum? Are we dealing with a maximum or a minimum parabola? By that, if I have a parabola that looks like that, that's a minimum. If I have a parabola that looks like that, that's a maximum. So what it's really asking you is, does the parabola open up or down? Which it just asked you, the previous question. So this goes with this. This always, if it opens up, that goes with minimum. If it opens down, that goes with maximum. So it's a maximum. Equation for the axis of symmetry. Well, we know where the vertex is. The vertex is at -2 plus 4. It's right there. We also know that it opens down, and my axis of symmetry runs right through the middle of it as a vertical line. So what is the equation of that line?
Would be -2.
That's a point. What's the equation of a vertical line? X equals -2.
Oh.
Okay, the equation of a horizontal line is y equals some number. So whenever you're defining lines, and notice that they want the equation for the axis of symmetry. Well, the axis of symmetry is that entire dotted line. So they're looking for the equation of a line. And I'm guessing that if you were to put -2, you'd lose a point or two off of it. You might not lose full credit, but you want to write the equation of the line. Change the function from vertex form to standard form. Okay, let me erase some of the stuff I have here. That's a pretty easy thing to do. Remember, standard form is this. That is standard form for a quadratic. So the only thing we have to do is multiply this out and apply the negative sign and combine the final number with the 4 to see what C is equal to. So square x plus 2 and square it before we apply the minus sign. In other words, this is going to be this times, what is x plus 2 squared equal to?
It's x squared.
Yeah, okay. FOIL it if you have to. It's actually better to memorize how to square two terms like that, but
plus 4x.
Okay, good.
Plus 4.
Okay. Plus this 4. So now apply the negative sign and combine the numbers.
So would that be x, negative x squared minus 4x. And then would be plus 4? Or
No, when you apply that negative sign to that plus 4, it turns it negative.
so it would be minus 4 plus 4, so that would be 0.
Okay. So there is standard format. C is equal to 0. And we make that 0 instead of y once we get it in standard format. Okay. Now, once you have it in standard format, remember, standard format, what is A in this case? These letters, A, B, and C. Those are important when you go to use the quadratic formula. That's where you get A, B, and C from, is from what you're looking at. What's A? A is the coefficient of x squared. What is that?
1.
Negative 1. And what's the coefficient of the x term?
Negative 4.
Okay. So that's what you have. Now, you could also do one other thing here, and that's divide everything by negative 1, so you end up with x squared plus 4x equals 0. And that's also in standard format. Alright, so all we did to convert it to standard format was to multiply it out and then simplify and combine terms. Y-intercept. In other words, once we got it into standard format, we had x squared plus 4x plus c is 0. I don't need to write it, but the reason I wrote it here is because when you're in standard format, the y-intercept is always c. If this was 7, the y-intercept would be 7. Notice the y-intercept always comes when x is 0. So if you want to figure out what the y-intercept is there, I substitute 0 for x, and I've got 7. That's what y is going to be equal to. So when c is 0, then the y-intercept is 0. And the x-intercept is always 0 for the y-intercept. That's what the y-intercept means, is x is 0. So the answer here is 0, 0. Sketch a graph with the vertex and y-intercept. Okay, let's go back. Start with the vertex. Vertex is at -2 plus 4. The y-intercept was at 0, 0. Where is the other x-intercept?
About -3.
What is this point right here?
-3, 0.
How far away from the y-axis is the vertex? It's 2, right?
Yeah.
So, since that's the line of symmetry, this distance between here and here is 2. This distance then has to be 2 because of the symmetry of it. So what is this x-intercept? What are the coordinates on it?
-4, 0.
Yeah. Now I've got 3 points. I've got both x-intercepts and a y-intercept. And there's my graph. And 3 points define a parabola. So any 3 points that you make are going to determine a parabola, but the 3 that most teachers want are the vertex, the x-intercepts, and usually the y-intercept. So really they want 4 points, typically. Alright, so now we need to go to the next page, and same thing, more of the same. Which way does this parabola open?
Does it open up?
Uh-huh. Where's its vertex? In other words, when you start in standard form, there's another equation that you need to figure out its vertex. You got 2 ways of doing this. You can complete the square and put it in vertex format, or you can use the fact that the x-coordinate of the vertex, or the line of symmetry, is equal to -b over 2a. Have you been taught that?
Yes.
Okay. What's -b over 2a here?
would be -6 over...
Hold on. What's b? B is that coefficient.
Yeah, so it would be -6.
Hold on. If b is -6, then what is minus b?
6.
Okay. What's a?
Is that 1?
So 2 times a is 2. So the x-coordinate of the vertex is 3. So it's relatively simple to come up with the x-coordinate of the vertex by this method. Now, to get the y-coordinate of the vertex, plug in the x-coordinate into your equation and see what y is equal to. So I'm going to say y equals 3 squared minus 6 times 3 plus 12. What is that number? Do it piece by piece. What's 3 squared?
9.
Minus 6 times 3, which is what?
18.
Plus 12. And still do it piece by piece. Actually, maybe doing this piece by piece is not the best way to do it. Notice that the easiest way to do this is to add 9 to 12. They're both plus. That's 21. And then subtract 18. So that's also equal to 3. If you do it piece by piece and you do this step first, you get, that's minus 9 plus 12, still gives me 3, but it forced me to deal with this negative 9. And by doing it out of order, I can avoid dealing with that negative 9. In other words, if I add all my positive numbers together and then subtract my only negative number, I don't have to ever deal with a negative number. It's 21 minus 18, and that's 3. So my vertex is 3, 3. We're going to have a maximum or a minimum on this problem?
We're going to have a minimum.
What's the equation for the axis of symmetry?
It's x equals 3.
What is the y-intercept?
Would that be 0, 3?
Remember, we are in standard format, and that y-intercept is always c.
Oh, so it's 12.
Plus 12. So, sketch the graph, okay? I'm going to start at 3, 3, right there. I know it opens up, right? And I know the x-intercept is 12. So I'm looking at a parabola that does something like this. I meant the y-intercept is 12. Do I have any x-intercepts?
No.
I don't. I need a third point. If I'm going to graph this thing, so far I only have 2 points. This is 0, 12. This is 3, 3. What's this point right here?
It's 6, 3.
6, what? The y is the same.
Oh, 6, 12.
There you go.
Sorry.
Don't miss out on the visual cues. In other words, when you're looking at it, make sure that, oh, okay, I know this y-coordinate is going to be the same y-coordinate of that. because of symmetry. And the line of symmetry runs right through it. We don't need to graph the line of symmetry, but they did ask for it, so, and that answers that. So graphing these parabolas always comes down to starting with the vertex. And if it's in vertex format, wonderful. You can solve it right off the get-go. If it's in standard format, you have to either use that minus b over 2a to come up with the x and y coordinates, or you could complete the square. Now, since completing the square is one of the problems on here, let's solve this by completing the square, just so you get some practice at it, and you can see why completing the square allows you to come up with the vertex very quickly. Remember, this is vertex format. Where h and k are the vertex. So if I can get this x squared minus 6x plus 12 into vertex format, I'll have the vertex. And it might be easier to do than the previous method, which there was quite a bit of arithmetic in that previous method. We had to figure out what minus b over 2a was, and then we had to substitute that in for x to figure out what y was. So this could be an easier method. Now, completing the square here is a little different than before, but not really. The trick on completing the square is to make sure you don't change anything. Notice I haven't changed anything yet. In other words, I left the 12 on the right side. Why? Because that's on the right side. So I know that I'm always going to have a number at the end of this thing. So I leave the 12 over there. Now, complete the square inside the parentheses for me.
Would that be 9?
Plus 9. Well, I can't add 9 to the right side of the equation without doing something else. You don't really want to add 9 to the left side of the equation, but I can subtract 9 from the right side of the equation. Notice I didn't change anything. I added 9, I subtracted 9. As long as I do it to the same side of the equation, I'm not affecting anything. Now, I'm in vertex format. What's my final answer? What linear factor squared does this become?
Does it become x squared?
No, remember it's a linear factor.
X minus 3?
Correct. Squared. Plus what?
Plus 3.
There. In one step, maybe 2 steps, we converted it to vertex format. Now you're looking at the vertex. There's h, there's k. So to my thinking, figuring out the vertex of this thing was actually easier to complete the square than it was to do the minus b over 2a. I just looked at my clock. I have a 7 o'clock that I'm 1 minute late for, so I'm going to have to run. And
Okay, we'll be talking to you.
I'll talk to you the next time, and we can pick up from here if you're still working on this.
Thanks, David.
You're welcome, David.
Good night.
Talk to both of you later.